Hello, today we are covering lesson 4.2, angles of triangles. You guys will be able to prove and apply the triangle angle sum theorem and prove and apply the exterior angle theorem. We have 3 new vocab: exterior angle, remote interior angles, and corollary. So our first theorem is the triangle angle sum theorem, and this basically states that the interior angles of a triangle add and equal 180. The sum of these measures of the angles of a triangle is 180 in words, and then you can see by the written out equation that we will take the angle measures of angle A, angle B, and angle C and add them up. I'm sure you've heard of that before, okay? So we do have a proof here. Now there's 2 different reasons we prove something. Today's 2 proofs are just so that way we can use these theorems forever and ever. They work in every single situation. Other proofs that we do, that I have you guys do, are like certain specific situations based on the geometry that we have. So this proof is just so we know that it is actually true. So we start out and we are only given that ABC is a triangle. From there, we are trying to prove that the measures of the interior angles 1, 2, and 3 equal 180. So we can take a big leap and say that there's a line AD parallel to BC through point A. If you recall, we talked about the parallel postulate. That is what you can say for that, okay? We also then move on to step 3. We know that angle 4 plus the measure of angle BAD, they form a linear pair. So that's just the definition of a linear pair. They form that straight line. We can call them a linear pair. They're adjacent. We know all linear pairs are supplementary. So this next reason for 4, kind of a longer reason. 2 angles form a linear pair are supplements. Most of the time reasons are not full sentences, but that's okay. That's what this reason is. And once we know that they are supplements, we know that supplements add and equal 180. So by the definition of supplementary angles, measure of angle 4 plus the measure of angle BAD equals 180 degrees. Now, most of the time, I would say you would probably, in your brain, skip straight from step 2 to step 5 and not even realize 3 and 4 were going on in the background. So just keep that in mind. Then, if you look at angle BAD, he is actually made up of 2 smaller angles, angle 2 and angle 5. That means that by the angle addition postulate, we can add them. And then we can take substitution and say, well, the measure of BAD shows up in both of these. I can replace the measure of angle 2 plus the measure of angle 5 in there. And I have the measure of angle 4 plus the measure of angle 2 plus the measure of angle 5 equals 180 degrees. So I've kind of finished that part of it, and then we have another part of our proof. So if we look at the picture, I would suggest if you are not in the habit of looking at pictures, make sure you look at the diagram. It's how you know where to go next most of the time. We have 2 parallel lines and a transversal. I can tell that angle 1 and angle 4 are alternate interior angles. So by the alternate interior angles theorem, we can state that angle 1 and angle 4 are congruent. We can also similarly state that angle 5 and angle 3 are congruent. Then, by the definition of congruent angles, we can go from congruent to equals for step 9. And then lastly, since we know 4 is equal to measure 1, We can do some substitution in there. For angle 1 and angle 3. And we get our prove statement. Now some of you wanted to write the word proven down here, or prove, as your last reason. That's not a valid thing that we can say. Instead, we can use substitution in this particular case. And then we're done. We have our last statement matching up with our prove statement. All right. So now that we've proven that, we know beyond a doubt that all triangles' interior angles add and equal 180 degrees, so we can use it to solve. So the diagram shows a path of the softball player in a drill developed by 4 players. Find the measure of each numbered angle. Now you won't always go in the order that you're given. You might solve for angle 3, then 1, then 2. That's totally fine. In this case, I am going to go in the order that's given though. So I have the triangle right here. I know that 43 plus 74 plus the measure of angle 1 has to equal 180 degrees. So I add these things. I get 117 plus the measure of angle 1. So my answer for the measure of angle 1 is equal to 63 degrees. Now the measure of angle 2 is pretty easy to get from there. They are vertical angles, which means that the measure of angle 2 and the measure of angle 1 are congruent. So they're both 63 degrees. Then we find the measure of angle 3, similarly to how we found the measure of angle 1. 63 plus 79 equals the measure, plus the measure of angle 3 equals 180. 63 plus 79 equals 142. We finish solving. And we get the measure of angle 3 equals 38 degrees. And we are good to go then. We found the measure of all of our missing angles. This next one, super similar, although we only need to find the measure of angle 3. It's just without the picture beside it, or the softball picture beside it. So, we're going to use the triangle angle sum theorem to solve for angle 3 to begin with, or angle 1 to begin with. Kind of have to solve 1 and 2 to find the measure of angle 3. So 38 plus 67 is 105. Finish solving. And the measure of angle 1 is equal to 75 degrees. Once again, the measure of angle 2 is vertical to that, so it's also equal to 75 degrees. And then we can solve, because this is 75, we can say 75 plus 48 plus the measure of angle 3 has to equal 180 degrees because of the triangle angle sum theorem. So the measure of angle 3 after we solve is equal to 57 degrees. And that's our actual answer because we only had to find the measure of angle 3. Okay. Let's go ahead and move on to the next problems. We're adding in a little bit of algebra here. We need to solve for x and then each measure of the triangle. Once again, you just add up all of these. And equal them to 180. Combine like terms. This one's a little weird. When we solve, we end up getting that x is equal to 0. That's okay. Our x value can be 0, our x value can be negative, it can be positive as well. When we plug it back in, we just want to check to make sure our angle measures actually equal 180 degrees. So the measure of angle A when I plug it in is going to be 60 degrees. B is 75 degrees and C is 45 degrees. If you add all those up, they actually do equal 180, so your x value is 0. Similar here, when you see a little box in the corner, that just means 90 degrees, so don't get confused by that. We are going to add the angle measures up. So each angle, all three angles are added and equal to 180. And then I solve for x. And x will equal 5. Now I once again need to find the measure of each angle. Measure of angle B is pretty easy. We already know that's 90. Now, there's a couple ways you can solve for this. The first way, well, go ahead and solve for one angle. I know 4 times 5 is 20 degrees. We can either just plug this in for x. That'll work every time. Or you can say, well, I know that 20 plus 90 has to then add with angle C to equal 180. 20 plus 90 is 110. 180 minus 110 has to equal 70. If you plugged x in, you would also see that 13 times 5 is 65 plus 5 equals 70 as well. So either way you solve, you'll still get the same solution for your answers. We also have a part 2. This is the exterior angle theorem. So in addition to its 3 interior angles, a triangle can have exterior angles formed by one side of the triangle and the extension of an adjacent side. Each exterior angle of a triangle has 2 remote interior angles that are not adjacent to the exterior angle. So in this case, on this picture, our exterior angle is formed by this side of the triangle and the extension of this side of the triangle. So angle 4 is our exterior angle, and angles 1 and 3 are called our remote interior angles. So we have an exterior angle theorem. This basically is a shortcut saying that if you have an exterior angle of a triangle, it is equal to the measure of the 2 remote interiors. So this measure of angle 1 equals the measure of angle A plus the measure of angle B. And we have a proof for this. So we start out knowing that just ABC is a triangle. And that's given to us. Then we have that A1 and angle 2 are a linear pair. This is very similar to the last proof. This is just definition of linear pair. I would suggest if you're not looking at the pictures, do it. Angle 1 and angle 2, they're a linear pair. They're adjacent, they form a straight line. Angle 1 and angle 2 are supplementary. Once again, this is the long one. 2 angles form a linear pair. Pair are supplements. And if we know that they are supplementary, we know by the definition of supplements that angle 1 plus angle 2 has to equal 180. Then we have the measure of angle A plus the measure of angle B plus the measure of angle 2 equals 180. Since we have proven the triangle angle sum theorem, we can use that in any further proofs. So I'm going to use it here to state that this angle A plus this angle B plus this angle 2 add to equal 180, which we used in the previous slides. Now, By substitution, we both know that 180s are the same. So I can take this guy, substitute him in. I can take this guy and substitute him in. And by substitution, property of equality, or subs, I can make these equal. Now this proof here is a little sloppy. It'd probably be better if we showed out the subtraction property of equality step and then said subs for step 7. Because that's not how it is, I'm going to say subtraction property of equality here. And then I'm going to say subs also in that step where we have got into our prove statement. And then I'm done. So now, because I have proven that, I can use the exterior angle theorem forever. It works when we have triangles. Okay, so now we are going to find the measure of angle FLW using the exterior angles theorem. So we have our two remote interior angles in comparison to this exterior angle, which means we can take x plus 32 and simply equal that to 2x minus 48. And then solve for x. So x is going to equal 80. Now we're not done yet. We have to plug that back in. So we take 2 times 80 minus 48. We get 160 minus 48, which will equal 112 degrees. So the measure of angle FLW equals 112. Okay? You could also go ahead, because you know these two add and equal it, plug in 80 there and take 80 plus 32. That also equals 112 degrees, or the measure of FLW. So it's super similar, it's just a picture now. The piece of a quilt fabric is in the shape of a right triangle. Find the measure of ACD. So we take 90 plus x, equal that to 3x plus 10. Solve for x. $80 equals 2x. So x is going to equal 40. Once again, we can just plug this guy in. So 3 times 40 plus 10. 120 plus 10 equals 130 degrees for the measure of angle ACD. All right, almost there. We have corollaries. Now, corollaries are not quite as powerful as theorems or postulates. They're kind of directly based on them, but they're like a secondary idea based on the triangle angle sum postulate theorem. I would go ahead and highlight these, though. They are pretty important. The acute angles of a right triangle are complementary. We know a triangle can only equal 180 degrees if we have a right triangle. That means 90 of those degrees are taken up, and the other two angles can only take up 90 other degrees. They have to take up those 90 other degrees, which means they must equal 180, or sorry, they must equal 90, which is complementary. And then 4.2, there can be at most one right or obtuse angle in a triangle. Say this guy was 100 degrees. If you had a 90 degree angle over here, that means we'd already be over the 180 degrees possible in a triangle. So you can only have one of those per triangle. If any at all. You could have 3 acute angles as well. These last 2 slides, we are going to find angle measures in right triangles. These are actually some of my favorite problems, and once again, you don't necessarily have to go in order, and you also might have to find this missing angle down here to find other ones. So it's kind of like a puzzle. You just start somewhere, and then use what you know to get to where you're trying to go, okay? So I'm going to start with 3, actually. I know that whole angle is going to be 90 degrees. which means 48 plus the measure of angle 3 has to equal 90 degrees. I solve. I get 90 minus 48 is equal to 42, so the measure of angle 3 is equal to 42 degrees. All right, and then the measure of angle 1, I'm actually going to use that exterior angle theorem. Angle 1 is exterior to this triangle with angles 48 degrees and 56 degrees being remote interiors. So I take 48 plus 56 and equal that to the measure of angle 1. 48 plus 56 is 104 degrees. So that is the measure of angle 1. Angle 1 and angle 2 are a linear pair. So I know they form a straight line, which means I can take 180 equal to 104 plus the measure of angle 2. I can solve here and I get 76 is the measure of angle 2. Now I need to solve for 4 and 5 as well. If I solve for the measure of angle 4, I already know 2 is 76. I am going to actually need to find that question mark angle. So I take 90 minus 34, and I get that this angle equals 56. I can use the triangle angle sum theorem to take 56 plus 76, and then subtract that from 180 to find the measure of angle 4. So I get 180 minus 132 equals the measure of angle 4. So the measure of angle 4 is 48. And then one more, I believe, angle 5. Angle 5, I just take 90 plus 41 plus the measure of angle 5 and equal that to 180. So that's 131. Go ahead and subtract. So the measure of angle 5 is equal to 49 degrees. All right, so we went out of order, had to use an angle that wasn't actually marked. No big deal though. Hopefully we got that pretty easy. This last one, we are going to once again use the puzzle pieces to find our angles. Now it does say just to find the measure of angle 3. I'm going to go ahead and find them all just so you can see everything that we do. So to find the measure of angle 1, I take 45 plus 85 plus the measure of angle 1 and equal that to 180. 45 plus 85 is 130. Which means the measure of angle 1 when solved is equal to 50 degrees. So if this is 50, the measure of angle 2 by vertical angles theorem is also 50 degrees. Then I can use the then I can use the exterior angle theorem backwards because I have my exterior angle and one interior angle to solve for the measure of angle 3. So 50 plus the measure of angle 3 plus 135. We go ahead and solve. So the measure of angle 3 must be 85 degrees. Then we know that 135 and the angle 4 must equal 180. So measure of angle 4 plus 135, because they're a linear pair, equal 180. I subtract those. I get the measure of angle 4 is equal to 45 degrees. And then I can use the triangle angle sum theorem. I can use the exterior angles theorem to say 45 plus 75 has to equal the measure of angle 5. So the measure of angle 5 must be 120 degrees. So I found all 5 angles. based on what I knew. All right, have a great afternoon.